Hi all, in this video we are going to solve a problem based on separately excited DC generator. So we'll directly go to the problem and look at here. The problem is a 250 volt 10 kilowatt separately excited generator has an induced EMF of 255 volt at full load. If the brush drop is 2 volt per brush, calculate the armature resistance of the generator. So these are the given parameters and we need to find the value of RE, armature resistance. So before that, you start with given parameters. So solution, so given terminal voltage Vt is equal to 250 volt and power P is equal to 10 kilowatt and induced EMF Eg or E is equal to 255 volt. Next, brush drop V brush is equal to 2 volt per brush, right? And in this question they have not mentioned the type of winding, whether it is lap winding or wave winding generator. So we can assume the given generator armature conductors are wound on the category of so they are given V brush which is equal to 2 volt per brush. So they have not mentioned to avoid or exclude the drop across the brush. So we need to include the brush, right? Because in some questions they will be mentioning to avoid brush drop, right? But here they have not mentioned like that. So we need to consider V brush or the drop across the brush while solving the problem, right? So we need to find to find the value of RA, right? So for this let me draw a diagram first for DC separately excited generator. So this is the field coil and this is the armature and these two are the brush. So it will get two brush. Normally there will be two brush. So the brush will be two numbers for this question, right? So this is the excitation current DC supply for field winding DC supply. Next, this is AAA, this FFF or excitation coil, and the current from this armature will be IA, and this is the generator, and the conductors will have RE resistance. This needs to be calculated, right? Now this is connected to a load. And the current here will be, or flowing through the load will be IL, right? So where from this diagram IA equal to IL in separately excited generator, right? So the voltage across this load will be this load will be Vt, which is equal to 250 volt. They are given in the question, right? Vt means terminal voltage. Terminal voltage means voltage across the load, right? This is not the input voltage. Vt means terminal voltage. Terminal voltage is otherwise is the voltage across the load, which is equal to 250 volt. So from this we can calculate the value of IL, right? Load current. If we calculate the value of IL, then we can find IA, because IA is equal to IL, right? So if we found the load current, then it is equal to armature current. So for that we know the expression. So solution starts from here. So P is equal to Vt into IL, Vt into IL. So where P is equal to 10 into 10 to the power 3, 10 kilowatt is equal to Vt is equal to 250 into IL. So from this, IL is equal to 10 into 10 to the power 3 divided by 250. So IL is equal to 40 amps. IL is equal to 40 amps. Right? So next we need to find the value of IA. So where IA is equal to IL from the diagram. So IA is also equal to 40 amps, right? We know that now we can write E is equal to, we can write the EMF equation of separately excited generator. E is equal to V suffix T plus drop across the armature conductor or armature winding, which is IA RA plus V brush. So this is our expression. Now we are going to substitute the values in this expression. We know the value of E, so which is 255 volt, which is equal to Vt is 250 volt plus IA is 40 amps into RA we need to find, plus V brush is equal to 2 volt per brush into 2, so 2 into 2 which is 4. So as I already told, here number of brushes is equal to minimum 2. They are not mentioned the type of winding, so we can assume the minimum number of brushes. So a DC generator will have minimum 2 brushes. So here V brush drop is equal to 2 into, so 2 volt per brush, 2 voltage per brush is a drop given in the question. So 2 into, there are two brushes, so 2 into 2 which is equal to 4 volt. So this is the brush drop or voltage drop across the brush. So now replacing this 4 or including this 4 volt in the given equation, so or in the EMF equation, so 255 equal to 250 plus 40 RA plus 4, right? Now we can write this equation as 255 equal to 250 plus 4 plus 40 into RA, so which is equal to 255 is equal to 254 plus 40 into RA. So 255 minus 254, I am bringing this 254 side, so it will plus will get a minus 10 to minus, so 255 minus 254 equal to 40 into RA. So where RA is equal to, when I subtracting these two values, 255 minus 254, I will get 1. So RA is equal to 1 divided by, so this will be replaced in denominator. So RA is equal to 1 by 40. This can be written from this equation, that is 1 is equal to 40 into RA. So from this we can write RA is equal to 1 by 40. So RA is equal to 0.025 ohm. So this is the value for armature resistance of the given question, right? Thank you.